Have you ever wondered if there might be more to our universe than meets the eye? Could there be hidden dimensions we're yet to discover? Our reality as we perceive it is three-dimensional. We live in a world of up and down, left and right, and forward and backward. These are the dimensions that define our physical existence and our interaction with the world around us. But what if I told you that there might be more? That our universe could be home to dimensions that are hidden from our senses, yet play a crucial role in shaping the reality we experience? This is where the enigma of hidden dimensions enters the stage. In theoretical physics, the concept of dimensions extends beyond the three that we're familiar with. Physicists propose the existence of extra dimensions, dimensions that are not directly observable, but whose effects can be felt indirectly. These hidden dimensions, they suggest, could hold the key to some of the most profound questions in science. From the origins of the universe to the true nature of reality, the existence of hidden dimensions could revolutionize our understanding of the cosmos. And while these dimensions remain hidden to our senses, they have become a focal point of research in theoretical physics. Theories such as string theory, which we'll explore in more detail later in this video, propose the existence of up to 11 dimensions. These theories suggest that our familiar three-dimensional universe is just the tip of the cosmic iceberg. But how can we hope to uncover these hidden dimensions? What tools do we have at our disposal to explore realms of reality that lie beyond our everyday experience? And what implications could the discovery of hidden dimensions have for our understanding of the universe? These are the questions we'll seek to answer as we delve into the enigma of hidden dimensions. So buckle up for a journey that will take us to the very edge of scientific understanding and beyond. So, are there more dimensions than we can perceive? Let's delve into history to find out how our understanding of dimensions has evolved. The concept of dimensions wasn't always as it is today. It's evolved greatly over time. Indeed, our understanding of dimensions began with a rather simplistic outlook. Ancient philosophers like Euclid, armed with nothing more than a piece of chalk and a blackboard, set the foundation for the concept of dimensions. They understood the world in terms of length, width, and height, which we now refer to as the three dimensions of space. Fast forward to the 17th century, when Sir Isaac Newton revolutionized our understanding of the universe. He introduced the concept of time as the fourth dimension, seamlessly weaving it into the fabric of our three-dimensional space. This opened up a whole new perspective, transforming our understanding of the universe from a static entity into a dynamic, ever-changing cosmos. The 19th century brought a new wave of thinkers like Albert Einstein, whose theory of relativity further enriched our understanding of dimensions. He proposed that space and time are not separate entities, but intertwined in an inseparable continuum known as space-time. Despite these groundbreaking revelations, physicists were still grappling with a conundrum. How do we reconcile the world of the very large, governed by general relativity, with the world of the very small, ruled by quantum mechanics? This puzzle led to the development of new theories and the exploration of even more dimensions. The 20th century saw the birth of string theory. This theory suggested that the fundamental building blocks of the universe are not point-like particles, but tiny vibrating strings. And here's the kicker. String theory proposed the existence of extra dimensions hidden from our perception. This revelation was a game changer. It suggested that our universe could be much more complex and far more interesting than we could ever have imagined. It paved the way for a new era of theoretical physics where the exploration of these hidden dimensions could hold the key to unifying all of the forces of nature. With the advent of string theory, however, our perspective on dimensions took a radical turn. And so, our journey through the history of dimensions continues. String theory opened up a whole new world of possibilities, introducing the idea of extra dimensions. To understand this, let's take a quick dip into the basics of string theory. You see, instead of picturing tiny particles like electrons and quarks as point-like entities, string theory describes them as tiny, one-dimensional strings. Now, what makes string theory truly fascinating is that it requires more than the three spatial dimensions we're familiar with for these strings to vibrate in. In fact, string theory postulates the existence of 10 dimensions. That's right, 7 extra dimensions, lurking somewhere we can't directly perceive. So, what's the role of these hidden dimensions within the framework of string theory? Well, they're critical for the string's vibrational patterns. Different patterns of vibration give rise to different fundamental particles. Think of these strings like tiny violin strings, and when plucked in different ways, they produce different notes, just as strings vibrating in different ways give rise to different particles. But where are these extra dimensions hiding? Why can't we see them? The most common theory is that these dimensions are compactified or curled up on extremely small scales, much smaller than we can currently detect. This idea of compactified dimensions is akin to walking on a tightrope. From a distance, a tightrope appears one-dimensional, a simple line, but up close we realize it's actually three-dimensional, with the additional dimensions curled tightly around the visible length. To wrap our heads around this, imagine a tiny ant walking along the tightrope. To the ant, the tightrope is a three-dimensional world, but to us, it appears as a single line. Similarly, the extra dimensions proposed by string theory could be all around us, but curled up so small that they're beyond our current means of detection. But string theory wasn't the only one to propose extra dimensions. Enter the Kusa-Klein theory. The Kusa-Klein theory, although lesser known, made a significant contribution to the concept of extra dimensions. In the early 20th century, two theoretical physicists, Theodore Kusa and Oscar Klein, independently proposed a theory that aimed to unify the fundamental forces of nature, namely gravity and electromagnetism. The Kusa-Klein theory suggested that our universe might actually be five-dimensional, with the fifth dimension being compact and tiny, almost impossible to detect. Kusa and Klein proposed that if we could wrap our heads around the existence of this compact fifth dimension, we could then explain electromagnetism and gravity as different manifestations of the same fundamental force. In simpler terms, electromagnetism could be perceived as the force resulting from the motion of objects through this hidden dimension. It's certainly a mind-bending concept. Imagine an ant walking on a tightrope. To us, watching from a distance, the ant can only move forward or backward one dimension. But for the ant, there's a second dimension around the rope. It can walk along the rope or it can go around it. The second dimension is there, but it's compact and hard for us to see. That's analogous to the way we might be experiencing our universe. The Kusa-Klein theory, despite not being fully accepted or proven, opened up a new way of thinking about the universe and the fundamental forces that govern it. It paved the way for future theories such as string theory to further explore the concept of extra dimensions. The theory suggests a universe far more complex and intricate than we can perceive with our senses, with hidden dimensions that could hold the key to unifying all the fundamental forces of nature. It's like peering behind the curtain of reality, revealing a backstage filled with hidden dimensions, waiting to be explored. So, how do we actually find these hidden dimensions? Unraveling the mystery of hidden dimensions isn't an easy task, but scientists have their ways. In the realm of high-energy physics, particle accelerators play a pivotal role. These gigantic machines, like the Large Hadron Collider at CERN, accelerate particles to near light speed and then smash them together. The resulting high-energy collisions produce a shower of various particles, some of which could be signs of extra dimensions. The rationale behind this? If extra dimensions do exist, they could alter the behavior of particles in ways that we can detect. For example, some theories suggest that gravity might leak into these extra dimensions, leading to deviations from the standard model of particle physics. But it's not just about detecting anomalies. The data from these experiments also helps in the construction of mathematical models, which in turn could provide a framework for hidden dimensions. Now you might wonder, with all these high-tech experiments, have we found any evidence of extra dimensions? Well, as of now, the answer is no, but that's not discouraging scientists. They continue to refine their experiments, improve their detectors, and crunch the numbers in their quest for the elusive dimensions. Another fascinating avenue of research involves black holes. Theoretical physicists have proposed that miniature black holes could form in particle accelerators if extra dimensions are real. These black holes would decay rapidly, producing a distinctive signature that could be detected. And then there's the mysterious world of quantum mechanics, which might also hold some answers. Quantum entanglement, for instance, could be a result of particles interacting through hidden dimensions. Interestingly, gravitational waves might also hold clues to the existence of extra dimensions. But that's a story for another scene. For now, let's stick to the hunt, the relentless pursuit of knowledge that pushes the boundaries of our understanding of the universe. The discovery of gravitational waves opened up new avenues in our search for extra dimensions. These ripples in the fabric of space-time, predicted by Albert Einstein over a century ago, were finally observed in 2015. But how do they link to the concept of hidden dimensions? Well, gravitational waves could potentially reveal the presence of extra dimensions. As these waves travel across the universe, they might interact with these hidden dimensions, altering their properties in ways that we could observe and measure. Imagine space-time as a sheet of rubber. When something massive moves, it creates ripples across this sheet, much like a stone thrown into a pond. If there are extra dimensions, these ripples might behave differently, giving us clues about their existence. The study of gravitational waves opens up a new window into the universe, one that could help us uncover its deepest secrets, including the existence of extra dimensions. But what if we do find these hidden dimensions? What then? The discovery of hidden dimensions would be groundbreaking, to say the least. This revelation would not just be a milestone for theoretical physics, but a seismic shift in our understanding of the universe itself. Imagine for a moment a universe where our current three-dimensional reality is just the tip of the iceberg. A universe where hidden dimensions hold the key to unlocking the mysteries of physics, from the enigmatic dark matter to the elusive unification of forces. The implications of such a discovery are profound. For starters, it would validate theories like string theory and Klein theory, which have long posited the existence of extra dimensions. It would provide a new framework for understanding the fabric of the cosmos, potentially leading to a unified theory of everything, a dream that has eluded physicists for decades. But it's not just about understanding the universe. The discovery of hidden dimensions could also have practical applications. For instance, it could open up new realms of technological advancement. Imagine a future where we harness the power of these extra dimensions for energy production, space travel, or even quantum computing. However, we must also consider the potential challenges. The detection and exploration of these dimensions would require cutting-edge technology and a radical shift in our scientific methodologies. It's a task that's as daunting as it is thrilling. Moreover, we would need to grapple with the philosophical and societal implications. How would our perception of reality change? How would this knowledge reshape our place in the universe? These are questions that we would need to answer as we venture into this uncharted territory. But despite these challenges, the search for hidden dimensions is a quest worth pursuing. It's a journey that takes us to the very frontiers of human knowledge and beyond. It's a journey that promises to redefine our understanding of the universe and our place in it. The quest for hidden dimensions is far from over, and the journey ahead is as exciting as the destination. The search for hidden dimensions continues to challenge and inspire physicists around the world. We've journeyed through the enigma of hidden dimensions, unraveled the history of our understanding, and dived into the realms of string theory and Klein theory, each offering a distinct perspective on these elusive dimensions. We've also explored the experimental hunt for these dimensions, from particle accelerators to the study of gravitational waves, each method opening up new possibilities and challenges. The implications of discovering these dimensions could be monumental, potentially reshaping our understanding of the universe and leading to groundbreaking technological advancements. Yet, the journey is far from over. The quest for hidden dimensions is a testament to our unending curiosity and the relentless pursuit of knowledge. It's a journey filled with questions, challenges, and the thrill of discovery. So, what are your thoughts on hidden dimensions? Share your views in the comments below, and don't forget to like, subscribe, and share this video with your fellow physics enthusiasts.